You know, it's one thing to think about how vast the universe is, but what really gets me is, well, the age of it all. We find things from ancient civilizations and we're amazed, but today we're talking about finding a star system that's almost as old as the Milky Way itself, a system called TOI 561.
It's an absolutely incredible find. We're talking about an estimated age of 10 billion years. This star is part of what we call the galactic thick disk, which is, essentially the oldest original part of our galaxy.
So it's like an original resident of the Milky Way.
Exactly. And the star itself is an orange dwarf about 275 light years away.
Yeah.
But the really fascinating part is that it's extremely metal poor.
Okay, let's unpack that. When you say metal poor, you mean it's mostly just hydrogen and helium, right? It's missing the heavy stuff.
That's right. And if you think about how planets are supposed to form, you need those heavy elements to clump together. So finding planets here.
It's a huge contradiction. So let's dive into that. What did NASA's tests find that's got everyone so excited?
The first big shocker is the innermost planet, TOI 561b. It's a super-Earth, a bit bigger than our own planet, about 1.4 times the radius.
Hey, here's the part that just blows my mind. It orbits its star in under 11 hours.
Less than half an Earth day. It's just whipping around.
I can't even wrap my head around that. The temperature alone must be insane.
Oh, absolutely. The equilibrium temperature is calculated at a searing 2,207 degrees Celsius. But beyond the heat, the real story is this huge scientific debate over what it's actually made of.
A debate, so we don't know for sure.
Not at all. You have two different teams looking at the same data, and they came to completely different conclusions.
How different are we talking?
Well, one study found a density pretty similar to Earth, suggesting a standard rocky planet, just maybe without a lot of iron.
Okay, so an ancient rocky world. Makes sense.
But then the other team found a much, much lower density. Their data implied the planet could be made of 50% or more water.
Wait, hang on. A water world that hot?
It wouldn't be liquid, of course. We'd be talking about a dense, puffy steam atmosphere. So you have these two possibilities: an ancient rocky core or a superheated, steam-shrouded world.
And that difference comes down to just tiny variations in the measurements, from 275 light years away.
It's all about how you model the data. The tiniest gravitational tugs, the smallest dips in starlight. It requires an incredible amount of processing power.
That level of computational precision, just to figure out what a world that old is made of, that requires some serious automation and data processing. Speaking of complex data, this deep dive is sponsored by Embersilk. If you need help with AI training, automation, or software development, they can help you figure out where AI agents could make the most impact for your business. Check out embersilk.com for all your AI needs.
So, okay, beyond this one dramatic planet, there's more to the system, right?
Oh, yeah. It's a whole system. There are at least 3 other confirmed planets, all mini-Neptunes. And even that was up for debate at first.
What do you mean? Well, initially one team proposed 3 transiting planets, and another proposed 4. But follow-up studies have now confirmed the 4-planet architecture, and are even hinting at a possible 5th planet that we can't see transit.
Wow. So what does a stable multi-planet system around a star, this old and metal poor, what does that mean for the big picture? It feels like it breaks all the rules.
It really does. It shows us that planetary systems can form even in the most resource-scarce environments of the early universe. And if that low-density watery model for TOI 561b is right, it supports ideas about planet migration.
So it formed farther out where it was cold and icy and then moved in over billions of years.
Exactly. It expands the playbook for how planets form and where we can find them. It offers so much hope that planet formation might just be the default setting across the galaxy, no matter the conditions.
That's an amazing thought, that the universe is just more creative, more resilient at making worlds than we ever imagined. It makes you wonder what other ancient systems dating back to the dawn of the galaxy are just waiting out there for us to find. The potential for discovery is literally as old as time itself. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.